Lesson 16, Science 8, and in this next series of lessons, we're going to apply our knowledge of forces in motion to explain a new phenomenon. We haven't really done that yet. I mean, we did investigations to uncover ideas about forces, but we haven't used these ideas to explain an event. That's what I want us to do over the next few weeks. Today, you're going to need a pencil, the journal slip, your science journal, and later on you're going to need a cup, scissors, and rubber band. Pause the screencast to get these materials now. In a moment, I'm going to show you a pretty cool video. The video shows several scientists working on a space mission. The team actually sent a space pod out into space, and then for a few seconds, the pod lost contact with Central Command. And when they regained contact, they saw that it was moving in an unexpected way. We're going to watch the video and then discuss what we think might have happened in those missing seconds. Pay close attention. Here we go.
All right, I've got systems up. Let's get eyes on the pod in the station.
Copy that.
Looking good. Registering expected speed. Target is ready to dock.
Anna, long time no see. So how's asteroid research going? What's the name of your project again?
Oh, the Asteroid Collection Mission? Call it the ACM for short.
Got any good samples yet?
Actually, I'm heading there right now because we have a pod ready to dock.
What did you get last time?
We got some dust and bits of ice.
Would you mind if I took a peek?
Actually, we don't have the samples here on Earth.
Really? Well, how do you study them?
Let me show you really quick. Our pod spacecraft is based at an unmanned space station, so it goes out to collect samples from the asteroid field. And then it flies back to dock and delivers them. Robotic tools in the space station allow us to analyze and photograph everything.
That is so cool. Oh, I'd love to hear more about that.
Well, the pod is docking right now. I'll let you know if we get any samples.
Good luck.
Want no coffee for us?
Very funny. Okay, this is Dr. Anna Gonzalez in Mission Control. Permission to start docking protocol.
Permission granted.
Okay, go for it, Greg.
Docking protocol activated.
Okay, 20 seconds. Nice and steady, just like last time, okay? Use the thrusters to reduce speed.
Copy that. Firing thrusters.
Okay, almost there.
No. What?
Okay, video's out. Somebody talk to me.
We've lost all communication with the pod.
Okay, try to reconnect.
Start up backup systems.
Backup system online. Still no contact.
Oh, we're back on.
Okay, what's the status?
Something's not right. It should have docked at the station by now.
Yeah, I can see it. It's going the wrong way. It's going away from the space station.
Something must have happened during those seconds when we lost contact.
Okay, Greg, I'm gonna need you to run a full diagnostic on the space station and the pod. Everyone else, I need you to reconstruct what happened in those missing seconds. I'm talking to the director.
Okay, now there's something you need to know about these space missions. They all have the same objective. They need to get the pod to stop and dock at the space station. Here, look at the screen. What's supposed to happen is the pod approaches the space station at medium speed. Then the thrusters, they fire to stop the pod, and then the pod connects with the space station. Now the thrusters or small engines were supposed to fire and stop the pod just as it reached the space station so it could dock and deliver the asteroid samples. But instead, when they regained contact, it seemed like it was moving in an opposite direction. Scientists at Central Command think that one of two things is possible. First, some think that the thrusters caused the pod to move in the opposite direction, claim one. But others think the thrusters may have slowed the pod down, but not enough, so it collided with the space station and then bounced off, moving in the opposite direction. Which of these claims makes the most sense to you, and why? Take a moment to choose a claim and decide why you agree with it. Do this on your journal slip. The first step in determining what happened to the pod is to come up with some possible reasons for why it would change its motion. To do that, we need to explore. Test objects to see what makes them experience a change in motion. We've already done this a bit in previous lessons, but let's do it another way. Remember, when you have multiple experiences, it helps you to develop a deep understanding. Here's where you need those materials. First, I want you to take your cup and cut it in half lengthwise like you see on the screen. And now go get that rubber band. What I want you to do is I want you to launch the rubber band at the cup and figure out all the ways you can get the motion of the cup to change. Hint, there's actually 5 different ways. Think of the cup like the pod from the video. We want to understand all the ways that something like the pod could change its motion. So take this chance to explore. As you figure out the different ways to change its motion, mark them on your journal slip. I'll wait while you do this. So what did you find out? How can the cup, or should I say pod, change its motion? Well, the cup could be still and start moving. The cup could already be moving and stop. The cup could already be moving and speed up. It could be already moving and slow down. Or maybe it's moving and it changed its direction. You should know that there's a word to describe movement in a certain direction. We're going to start to use that word from now on. Do you know what that science term is? It's called velocity. Velocity is speed in a particular direction. Those 2 parts are really important. It's not just how fast something's moving, but also the direction of the movement. Mark this on your journal slip. So let's apply this concept to the space pod. How to get the pod to change its velocity so it stops and docks with the space station. Are you thinking what I'm thinking? I'm thinking about Newton's first law. An object in motion will stay in motion unless acted upon by another force. So that's it. The thrusters must exert a force on the pod to get it to change its velocity and stop moving. But is this force in the same direction as the motion of the pod, or would the force be in an opposite direction? Let's play this out right now. I'm going to open up a simulation. And here you can see that this object is going to represent the pod, and here's the space station. So I can get it to start moving toward, and then as it gets closer, the thrusters are going to turn on. They're going to exert a force like you're seeing on the screen, but I'm going to put the force in the same direction as the motion of the pod. Let's see what happens. Seems like when the force was in the same direction, that pod moves faster toward the station. Now let's do it again. This time, when I run it, I'm going to have it approaching the space station. And then the thrusters are going to turn on, but they're going to exert a force in the opposite direction. Let's see what happens. It seemed like when it was in the opposite direction, it slowed down. So how did the thrusters exert the force? Well, yeah, it seemed like based on what we just saw in the simulation, the thrusters must fire and exert a force in the opposite direction of the motion of the pod to get it to slow down. You can mark this on your journal slip. So now that we've figured out what's supposed to happen, let's share our ideas for what you think happened in those missing seconds. Today, go to the discussion board and post the claim that you agree with and why. Do you agree with claim 1 or claim 2? Make sure to justify and make sure to respond to at least one peer on the discussion board. Oh, and don't lose that rubber band or that cup. You're going to need it for the next future investigation. Until tomorrow, keep thinking, keep learning, and keep the discussion going.